Hello everyone, my name is Pradipta Kandar. I am a sophomore at National Institute of Technology, Agartala. Today I am going to solve problem number C from Codeforces round 748 division 3. The problem first we'll go through the problem statement, after that we'll look at the approach, and after that we'll see at the implementation part. So the problem statement says there are one cat, k mice and a hole on the coordinate line. The cat is located at a point 0, the hole is located at point n, which you will be given, and all the mice are located between the cat and the hole. Note one thing, there can be any number of mice at a given point. There can be even be 0 mice at a given point. So moving on, in 1 second the following happens. First, exactly one mouse moves to the right by 1, and if the mouse reaches the hole, it hides. So you can move to the right in each second you can move to the right by 1, and if you reach the hole you are safe from the cat. And also the cat moves to the right by 1 in each second, and at the cat's new position, if there are n number of mice, all will be eaten by the cat. So your task here is to save the maximum number of mice from the cat. The whole run stops when maximum number of um, mice reaches the hole, or there are no more mice left to be eaten by the cat. Okay, so now we'll move to the approach part. So let us take a look at the approach. I will demonstrate the approach with the help of an example. So let us first draw the coordinate axis. And let us take the hole to be at some point. Let us make this point 10, and our cat to be at point 0, obviously, and there will be 9 points between this 0 and 1. So let me draw those points: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let me number these: 1, 2, 3, 4, sorry, 4, 5, 6, 7, 8, and 9. Now let us place the mice. Let us suppose there's a mice at point 9, there's a mice at point 8, there's a mice at point 7. So the time taken for this mouse at point 7 to reach 10 will be 3 seconds. For the mouse at 8 to reach point 10 will be 2 seconds. That is 10 minus 2, and the time taken by the mouse at point 9 to reach 10 will be 1 second. So the total time taken by all the 3 mouse to reach the hole will be 3 plus 2 plus 1, that is 6 seconds. Meanwhile, the cat is also moving simultaneously to point 6, because in 6 seconds it will reach point 6, because it moves by 1 unit per second. It will move like this and it will reach the point 6. Okay, now everything is fine and good. All the 3 mice will reach the point 10, that will reach the hole, and by that time the cat will reach point 6. Now let us consider a mouse at point 3. Now the time taken for this mouse to reach the point 10 will be how much? Will be 10 minus 3 is 7 seconds. Now 6 plus 7, we will get 13. That is the time taken for all the mouse for all the 4 mice to reach the hole will be 13 seconds, whereas the time taken by the cat to reach the hole will be how much? Will be 10 minus 0, that is 10 seconds. Now if we see one thing, the time taken for the cat to reach the hole is less than the time taken by all the 4 mice to reach the hole. So what can we conclude from here? We can conclude that there will be at least at least one mouse between 0 and 10, which will coincide with the cat while traversing the distance, while traversing the line between 0 and 10. And why is it so? Because since the cat is moving one step at a time, there should be a point where one of the mice and the cat will coincide, because the time taken by the mice for all the 4 mice is greater than the time taken by the cat to reach the hole. So the basic condition here should be that the time taken by the maximum number of uh, mice to reach the hole should be less than the time taken by the cat to reach the hole. So let me write it down for you. So the thing is, the total time taken by the maximum number of mice to reach the hole should be less than the time taken by the cat to reach the hole, which is nothing but n minus 0, which is equal to n, right? I hope this is clear. We can move on to the implementation part. Thank you. So let us take a look at the implementation. I have declared a multiset S here of type int. This stores the position of the mice. Why we used a multiset here? I have used a multiset here because there can be more than one mice at a same point, at the same coordinate point. So I have used a multiset here. So first let us take the input of the number of test cases. After that I have taken the input of n and k. N denotes the position of the hole and k denotes the number of mice. After that I have used a for loop for taking the input of the position of the mice, and I've inserted it in the multiset S. Now you will notice one thing, I have multiplied it by -1 before inserting. So this is a trick I have done for arranging the mice in a descending order. So the mice which will be closest to the hole will be at position 1, and it will continue, because like if a mice is at a point 9, and if a mice is at a point 8, so the point 9 number mouse will be closest to the hole if the hole is at 10, right? So I have used this concept to keep the coordinates in descending order. After that I have iterated through all the values in the multiset, and I have found the total sum of the distances of the mice, starting from the closest mice going to the farthest mice, and I have kept on accumulating it in the distance sum variable until the distance sum is greater than or equal to n, that is the distance between the maximum distance between the cat and the hole. Until uh, until it is less than n, I kept on incrementing the counter, because this counter keeps records of the maximum number of mice that could be saved from the cat. And after that I have outputted the counter, and I have reinitialized counter to 0 and distance sum to 0, and I have cleared the multiset. So we will see if it works. So let me take the input. So this is my input, paste it here. Let us copy the output, just paste it here and see if it works. So it says it is passed. Okay, thanks for watching.